All right, good morning, guys. Today we're going to be covering 7.3 Soh-Cah-Toa. This is all about right triangle trigonometry, and this is where we start getting into the important topics of this entire unit. So, Soh-Cah-Toa is just an abbreviation for our trig functions. Our trig functions being sine, cosine, and tangent. And you guys should be able to see these on your calculators. And that's very important that you guys locate those on your calculators and have your calculator ready because you'll be needing it for today. Now, what these trig functions do is they allow us to just use a couple things in order to solve for everything in a right triangle. So first off, these can only be used in a right triangle. So that's very important. And the only things that we need in order to use trig functions, we either need two sides or we need one angle and one side. If we have that information, and when I say one angle, I'm not talking about the 90-degree angle, I'm talking about one of the other two angles. If we have that information, then we would able to solve this right triangle using one of our trig functions. We'd be able to solve for all the side lengths and all the angle measures as well. So that is what makes trig functions so useful for us. What it does is these trig functions, we enter in a ratio of a triangle, so the side lengths of a triangle, and then it will give back a missing side length based upon the angle measure that we give, or based upon the ratio that we enter in, it will give us back an angle measure for that missing angle. So this is very useful in order to really master triangles. So let's go ahead and get started with a couple tips. And before I do that, just want to make sure I'm recording. Okay, awesome, I am. So first off, our first tip for Soh-Cah-Toa. This can only be used for right triangles. We just talked about that. No other chance of using it for right triangles. Now, the way that we always start, we always label our sides as opposite, adjacent, and hypotenuse. Now, there's three sides to a triangle, and each side is going to have its own unique name. I won't call one side the opposite and the hypotenuse. Each side will only have one name, and it needs to be very clear on which side you're talking about. Next, you must use a calculator. If you don't have a calculator, it's going to be very difficult to use trig functions. So on your calculator, make sure that you can find sine, cosine, and tangent. Again, they're just written as sine, cosine, and tangent. If you can find those on your calculator, you'll be able to do today's lesson. Make sure that you guys continue to practice these. It will make these easier in the long run. Oftentimes people have a little bit of trouble at the start, but once they get used to it, trig functions can become very simple for them. So make sure that you guys are doing that if needed. A couple other things. If you have a graphing calculator, meaning a TI 83 or greater, make sure that your calculator is set to degrees. It may be in radians. So in order to set your calculator to degrees, you need to go through a few steps. First, you're going to hit the mode button. The mode button is right next to the second button near the top of your calculator. Once you hit mode, about 3 spaces down, 3 rows down, it will say radian, and it'll say degree. If radian is highlighted, you're going to go down. You're just going to use the arrow keys on your calculator, go down, and then you're going to move over to degree, and you're going to hit enter on it. That will make degree highlighted. And then to get out of this, you're just going to hit the second button and then hit mode again. What that will do is that will close out of that window for you. And once you do this, it will set your calculator to degrees, which is all we're going to be dealing with, because we're going to be dealing with the angles. So we want our calculator set in degrees. Again, that'll be very useful for you to be able to go back to that page because you'll be using it quite a bit as you advance in your math studies. Lastly, when we are choosing our angle at the very start, because each problem will be given a different angle, when you choose your angle at the very start, you're always going to choose the angle that is not 90 degrees. We cannot use the 90-degree angle when we're choosing it. So never choose the 90-degree angle. We don't want it. So now let's go ahead and explore what Soh-Cah-Toa really means. So trigonometric functions. We have sine, cosine, and tangent. And this is how they're fully written out. Again, it's pronounced sine, cosine, and tangent. Now we can see that within Soh-Cah-Toa. The S, the C, and the T just stand for our actual trig functions. Meanwhile, the O and the H, the A and the H, and the O and the A, these are the ratios of our side lengths. So, for instance, let's go ahead and start with sine. We're going to do sine of angle A. And what this stands for, well, the O stands for opposite, and the H stands for hypotenuse. On the last slide, we were naming our sides. So what these other letters stand for are the sides in a ratio. So if I have sine of angle A, well then what I would do to start off with is I would look at what angle I'm working with. So in this case, it's angle A. And so I'd go over to angle A on my figure. From here, I would label my sides. So the side opposite angle A, I would have to go through the triangle. So little a is the opposite. C would be our hypotenuse, and B would be our adjacent. Again, our hypotenuse is going to be the longest side. It is always opposite the 90-degree angle. And then the adjacent is the side length next to our given angle that is not the hypotenuse. So typically our adjacent is the last one that we choose. Now, from here, if we look at this, it says sine is equal to opposite over hypotenuse. So that's where the O and the H go. They go inside the parentheses. Well, if I look at this, the opposite side is A, and the hypotenuse is C. So therefore, our ratio is A over C. Next, we can look at cosine. Well, again, these are just referring to the sides of the triangle that were given. So in this case, A will be adjacent, and H will be hypotenuse once again. From here, we can label our triangle. Since we're looking at angle A again, we're just going to have the same sides, and we're going to do that for each one. It'll be angle A for these. So this time, we have adjacent over hypotenuse. Our adjacent side is B. Our hypotenuse is C. So therefore, our ratio will be B over C. And again, we can see Ka, C-A-H. Lastly, we got Toa. Tangent is equal to opposite over adjacent. Again, if we look at angle A, we can label our sides. They're all the same ones once again. A is opposite, C is the hypotenuse, and B is adjacent. Again, the hypotenuse will always be opposite the 90-degree angle. Our opposite side will always be opposite whatever angle we're given. And then in this case, whatever's left is our adjacent. So again, we have opposite over adjacent. Opposite is A, adjacent is B. So we have A over B. And the reason why tangent is so useful for us is because if we look at this, if I'm looking at this angle here, this is the slope, rise over run. So tangent actually allows us to find slope as well. So very useful for us. Now again, this is how you'll be setting up all of your trig ratios. Always sine of whatever angle you're given is equal to opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent, based upon what you are given in your triangle. So next up, let's go ahead and practice drawing and labeling on a triangle. This time, we have sine of angle A and sine of angle B. Now, if we look at this triangle down here, we'll notice that we have an isosceles right triangle. It's isosceles because two of the legs are congruent, and it's a right triangle because we have 90 degrees. So typically, this would change what's going on with these a little bit, But it's not going to change too much as we go through this because, again, it's an isosceles right triangle. So we always start this off by writing out Soh-Cah-Toa. That's how we start off each problem. We want to make sure that Soh-Cah-Toa is written somewhere on there. Next, well, we look at what trig function we're using. And in this case, we're using sine. So therefore, we would use SOH. So we want opposite over hypotenuse. That's our goal. So we go over to the angle that we're looking at. In this case, it's angle A. And we're going to go ahead and label our sides from angle A. So in this case, 1 is opposite. Radical 2 is our hypotenuse, and you can see that because you can draw an arrow with the right angle, and it's pointing at the hypotenuse always. And then lastly, the other 1 is our adjacent. So we now have our opposite, hypotenuse, and adjacent. Now if we look at sine, that's dealing with opposite over hypotenuse. So our opposite is 1, our hypotenuse is radical 2, so sine of angle A is equal to 1 over radical 2. Next, let's try angle B out. So again, we're dealing with the function sine, so we can go ahead and write that right away. We're dealing with sine. And then we're looking at angle B this time. So if I want to label from angle B, I do the same exact thing. The side opposite angle B is 1, side length AC. Our hypotenuse hasn't changed. That won't ever change. It's going to be radical 2 here. And in this case, our adjacent is also 1. Now, since our opposite and adjacent are the same number, it's not going to do as much to this problem as we would think. Again, we're using sine, so it will be opposite over hypotenuse. Our opposite is once again 1. Our hypotenuse is radical 2. So sine of angle B is equal to 1 over radical 2 as well. All right, so that's just being able to draw and label a triangle with Soh-Cah-Toa. Next, we're going to be looking more so at the ratios. So next up, find trig ratios for angle A and angle B. So we have all of them here. Now, something important that's happening within these right triangles is that angle A and angle B are complementary angles. They'll add to be 90 degrees. And the reason that they're complementary is because angle C is 90. If there's 180 degrees total in a triangle, and angle A and angle B already add to be 90, well, I'm sorry, we're already using 90 from angle C, then angle A and angle B have no choice but to be 90 degrees. So that's how I know that they're going to be complementary. And since they're complementary, we're going to notice some relationships that occur when we write out all of the trig functions. So what I want you guys to do is look for patterns as we go through this. And look for anything that seems a little bit off, because it will be very useful for us to look at. So first off, I'm going to start by looking at the angles that we have. Soh-Cah-Toa is already written for us. So looking at this, we're going to start with angle A. So we're going to label our triangle based upon angle A. So the side opposite angle A would be 3. Our hypotenuse would be 5. And our adjacent would be 4. That's how we always want to start this off. From here, we're just going to go ahead and go through each trig function. So starting with sine. Sine is equal to opposite over hypotenuse, which would give us 3 over 5. Next, cosine is equal to adjacent over hypotenuse. So cosine of angle A is equal to 4 over 5. And lastly, tangent. Tangent of angle A is equal to opposite over adjacent. So that would give us 3 over 4. As we can see, all of our trig ratios are different for angle A. Let's see how they compare to our complementary angle, angle B. So this time we're focusing in on angle B. So now we need to relabel our triangle because now we're starting at a different focal point. So with angle B, the side opposite angle B would be 4. The hypotenuse doesn't change, that's still 5. And our adjacent side would be 3. Again, look for patterns. Look for anything that seems off or something that looks familiar. Starting with sine. Sine is equal to opposite over hypotenuse. So for angle B, that would be 4 over 5. Next up, cosine is equal to adjacent over hypotenuse. That would give us 3 over 5. And lastly, tangent of angle B would be opposite over adjacent, which would give us 4 over 3. Did you notice anything strange occurring with our ratios now? Well, yes. If I look at tangent of A and tangent of angle B, these are inverses. They're inverse numbers. The fraction is flipped. So that's automatically something that seems a little bit strange. Further, if I look at cosine A, it's the same as sine of B. And also sine of A is the same as cosine of B. So the complementary angles, their sine and cosine values, meaning 3/5 and 3/5, they're in fact the same. The sine of angle A is equal to the cosine of angle B, and the cosine of angle A is equal to the sine of angle B. So that's very useful information for us. And the reason that this occurs is because they are corresponding angles. And that'll play a really big deal once you guys get further into trigonometry and take a look at the unit circle. All right, at this point, we're going to go ahead and try out some practice problems for this. The first one that we have is we're going to solve for x and round to the nearest hundredth. So first off, we see that we have a side length of 11 meters. We have an angle of 62 degrees. We're trying to find x over here. So we only have 2 things in this triangle. We're trying to find a third. Now, the first thing that we need to do is we need to look at the angle. We always focus in on the angle first, and that's 62 degrees. From this angle, we're going to label our sides as opposite, adjacent, and hypotenuse. So the side opposite 62 degrees is 11. The hypotenuse is x, and we don't have anything for the adjacent side. It's just blank, so we just leave it as blank. From here, we look at what is actually on the triangle itself. That way we can determine which sides we're going to use. Well, I have the opposite side as 11 meters. I have the hypotenuse as x. Well, out of our 3 trig functions, which one uses opposite and hypotenuse? That would be sine. So we're going to use sine of theta equals opposite over hypotenuse. Again, this symbol is just theta. I'll talk a little bit about that later, but all you need to know for it is that it's a Greek letter that represents angle measures. That's what it's used exclusively for. It's used to show angle measures. So plugging in our values, we have sine of 62 degrees is equal to opposite 11 meters over hypotenuse x. From here, we can solve for x. Now, in order to do that, the first thing that we would do is we would multiply both sides by our denominator, x. That will leave us with x times sine of 62 equals 11. At this point, we're going to go ahead and get x isolated. Now we have multiplication occurring. Again, this whole thing is just a function. So it's just a function that's occurring. So we can just treat it all as one number. So I'm going to divide both sides by sine of 62, that entire trig function. They will cancel out on the left side, and we'll be left with x equals 11 over sine 62. That is what you want to enter in on your calculator. Now again, make sure that you're in degrees. We talked about that earlier. But if you enter that into your calculator, 11 over sine of 62, you'll be left with 12.458270056. But again, we're rounding to the nearest hundredth. So that'd be x is about 12.46. This is one of the more difficult ones because our x value is in the denominator. Let's see what a problem looks like if x is in the numerator instead. This time we're solving for QP. There it goes. We're solving for QP this time. So, to get started on this one, again, we must always start by looking at what angle we're given and labeling our sides from there. So we're given 38 degrees, so we're going to label all of our sides around this 38 degrees. So the side opposite 38 is blank, our hypotenuse is 25 still, and our adjacent is x. Well, what do we have on the triangle to use? Well, we have our adjacent as x, and our hypotenuse is 25. So we're going to use adjacent and hypotenuse, meaning that we're going to use cosine. So cosine is equal to adjacent over hypotenuse. Plugging everything into our trig function, we'll have cosine of 38 degrees equals adjacent, which is x, over hypotenuse, which is 25. Notice that this time our x value is in the numerator, which will make this solving a lot faster. If I want to solve for x, all I need to do is multiply both sides by the denominator. 25. Doing so would leave us with 25 cosine of 38 equals x. This is what we're going to enter in on our calculator. Doing so, 25 cosine of 38, doing so will leave you with 19.70026,884. But again, we're rounding to the nearest hundredth. So x will be about 19.7 millimeters. That makes sense as well. 25 is the longest side, our hypotenuse. So our adjacent side should be less than that. It should be smaller than 25. All right, let's go ahead and try out the next one. The next one's going to have some questions to get started as you guys begin. So here it is. Find the height of the tree. We have a 40-degree angle from the ground. We are 50 feet away from the tree, and the tree's height is h. Now, looking at this, what angle is given? Well, we're given the 40-degree angle. So that's what we're going to plan all of the rest of this around, that 40-degree angle. So from here, and again, like we said earlier in the video, never use your right angle when dealing with a right triangle trig. We don't want to use this angle. That would be bad for us. That'd mean that this is opposite and hypotenuse, which we can't have. So from here, label your triangle with opposite, adjacent, and hypotenuse. So again, opposite of 40 would be h, hypotenuse would be blank, and adjacent would be 50. At this point, what do we have on the triangle itself? Well, we have h, and we have 50. So we have opposite and adjacent. So that means that when we're doing Soh-Cah-Toa, we need opposite and adjacent. We're going to use tangent here. So tangent of theta is equal to opposite over adjacent. And again, theta is just that Greek letter used as a common variable for angles. That's where you're most likely going to see theta. Plugging in our values, we have tangent of 40 equals h over 50. If I want to solve, I need to get h by itself. So I'm going to multiply both sides by 50, and that will get h isolated. So therefore, we have 50 tangent of 40. If we enter this in on our calculator, 50 times tangent of 40, we end up with 41.95498156. Again, we're rounding, so it's going to be about 42 feet. All right, let's try out one final question. Lastly, we want to find the height of the geyser. So we have this geyser, it's shooting water into the air, and we want to find how tall the water is actually going, how far into the air it is. We're looking up at the top of the geyser at 63 degrees. We're 40.5 meters away from it, and we want to find the height. So, to get started, again, we look at what angle we're focusing on. In this case, it's 63 degrees, so we label our sides from there. H is opposite, blank side is hypotenuse, and 40.5 is our adjacent. So if we were to use Soh-Cah-Toa, what information do we actually have on the figure? Well, we have the opposite side, H. We have the adjacent side, 40.5. So therefore, since we have opposite and adjacent, we want to use tangent. So tangent of theta is equal to opposite over adjacent. Again, the angle that we have that's going to replace theta will be 63. Opposite is h. Adjacent is 40.5. So tangent of 63 equals h over 40.5. From here, we just want to solve for h. So I'm going to multiply both sides by 40.5, which will give us 40.5 times tangent of 63 equals h. Again, on the right side of our equation, the 40.5's canceled. From here, we can enter this entire thing on the left into our calculator. So if we do 40.5 tangent of 63, then we're left with, let me see, 40.5 tangent of 63, we're left with 49.48572547. But of course, we're rounding to the nearest hundredth, so that'll give us about 79.49 meters, which means that that water is shooting into the air 79 meters, which is pretty tall. All right, guys, thank you so much for watching today. If you have any questions, please let me know. But other than that, have a great